So let's keep trying to find and classify critical points for different functions. So we have this function right here, x squared plus xy squared minus 2x plus 1. And we want to find the critical values, or critical points in this case, because they're not just a value, they're a point x and y. All right, so f sub x would be equal to 2x plus y squared minus 2. And f sub y would be equal to 2xy. No, that's it, 2xy. Okay, so now remember, these both have to be equal to 0 at the same time, simultaneously. Now, luckily for us, the one on the right's really easy, because if 2 times x times y is equal to 0, then you know that either x is 0 or y is 0, or perhaps both. But we'll find out. So we're going to take these values and you're going to substitute them back in because you know they have to happen simultaneously. So you'd say, oh, okay, so what's fx at x equals 0? So we're going to take these values and we're going to plug them in back here. That would be 2 times 0 plus y squared minus 2 would have to be 0. So that's gone, right? Y squared would have to be 2, so y equals plus or minus the square root of 2. I can't forget that plus or minus that we learned about in Algebra 1 class a long time ago, right? Whenever you take the square root of both sides, plus or minus. All right, so let me write this down. Using x equals 0. All right, so now using y equals 0. So we're going to find f sub x at y equals 0. We're not going back into fy because fy is where we got these values from in the first place. So there's no need to go back there. So 2x plus 0 squared minus 2 equals 0. So 2x minus 2 equals 0. So x equals 1. Okay, so what are our critical points? So the critical values or critical points are 0 square root of 2, 0 negative square root of 2, and 1 comma 0. All right, so now that we have those critical points, we can build our table. So we're going to need a table. We're going to need the critical points, right? So we know there's 0 square root of 2, 0 negative square root of 2, and 1 0. We're going to need to know d, and we're potentially going to need fxx, and then we will draw our conclusions. Okay, well, to fill this out, we're going to need d. Now, to find d, it's not just d, it's to run the test, right? So let me do this. To run the test, let's find the pieces. So fxx, that's the second derivative with respect to x. So if I go back up here, that'd be 2. Right? Just 2, because the rest of these would be constant. So that's 2. Fyy would be 2x. Right? The derivative of this with respect to y is 2x. Fxy would be 2y. Right? The derivative of this with respect to y is 2y. Right? So we're going back to these two right here. Not the equal 0 part, but the rest of it. Okay. So then, putting that together, d is fxx times fyy minus fxy squared. So that would be 2 times 2, or excuse me, 2 times 2x. So 2 times 2x minus 2y squared. Parentheses, squared. The whole thing is squared. So that's 4x minus 4y squared. Okay, so now let's take our values and plug them in. If we put 0 in for x minus 4 times the square root of 2, we would have a negative number, right? If we put negative square root of 2 in here for y, once you square it, it's going to turn it positive, but then you multiply by a negative 4, and it's negative. Again, I don't need the number. I can just tell, right? 4 times 0 is 0. 0 take away 4 times something positive will be negative. Now if I put 1 in for x, right, and 0 in for y, that'll be 4, right? That's a positive number. Okay, so the only one I need fxx for, if you recall, is this bottom one, right? Because we only need to check fxx if our d is positive. So we need to check fxx, which is right here. It's a constant. And 2, last time I checked, is a positive number. All right, what does this show us? This shows us we have saddle points. Saddle point at 0, square root of 2. And then we never figured out the z value, so we can figure that out. And we have another saddle point at 0, negative square root of 2 something. So we'll figure that out in a second. And then positive, positive means we have a minimum at 1, 0, something. Okay, so how do we find the somethings? Well, we just take the values and we plug them back into the original. So if I put 0 in here and 0 in here and the square root of 2 in for y, I'm going to have 0, 0, 0, and 1. So that's really easy. So this is 1 and this is 1. They're going to be the same value. All right, what if it's 1 and 0? So 1 here, 0 for this one because y is 0. So 1 take away 2 plus 1 is 0. So, and again, of course, you could make a computer do that substitution if you wanted to. All right, let's look at this in Maple and see if it backs us up. All right, so it looks kind of like a bat wing. So we have our values. So we have saddle points on 2 of them, which are the 2 kind of in the back. And then we have a minimum right there. Right, see how it's lower at that spot than it is at these other 2. So there we go. So it is in fact backing us up. We have saddle points on 2 of them and a minimum right there on the low one. Right, that's a lower value than those other 2 because it's at 1, 0, 0. So I kind of like this view. I think you can see it really well. It looks sort of like a bat wing that way.